In this video, we're going to look at Pythagoras and trigonometry in 3 dimensions. Now, the whole idea of this is that you're finding right-angled triangles because Pythagoras works in right-angled triangles, and our trig, as in sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. They all work in right-angled triangles. So in this cuboid here that we have lots of right-angled triangles. We have the obvious ones here. The obvious ones here, you can see you have a right angle. You have a right angle, you have a right angle, you have a right angle, and ones which drawn in 3D don't necessarily look at it like a right angle. So that would be a right angle, that would be a right angle, that would be a right angle, and that would be a right angle. And on the top, you'd also have right angles as well, and that is it. You also have got right angles wherever there's a baseline and a vertical. So any baseline, so if I drew a line along my base, and then I've got this vertical height here, this would also be a right angle. So this here is a right angle triangle, which goes from H across to F and up to B. Okay, so you have lots of right angles. So if you've got a base, and let's just think about what your base is here. Your base is this surface. So any vertical line going up, there's a vertical line. That creates a right angle, but so does this as well. That also creates a right angle. There's a vertical line, and there's your base. This also is a right angle. So that's a difficult bit people have. So when you're doing this, always draw out the right angle triangle that you're looking at, and also label it. So when I say label it, you put whatever 3 letters are involved in it. Okay, let's get started with this question. It says calculate AC. Where is AC? So AC is here. So it's on this. So we look for a right angle triangle which involves A and C, and I'm going to use A, B to C. So my right angle is at B, so I'm going to draw a triangle for the first one here. This is part A. That's my A to B and then to C. My right angle is at B. And then we look at the diagram and think what these lengths would be. Now, G to H is 4. G to F, is 4, which means C to B would also be 4. So we can label this as 4. Also, H to G would be 6, which means D to C would be 6, which also means, because it's a cuboid, A to B would be 6. And then we can we'll put X for what we want to find. So this is AC. So X squared is equal to 6 squared plus 4 squared, which means X is equal to the square root of 6 squared plus 4 squared. And we do that on our calculator, and we leave it as an exact value for the we'll show the exact value. So 6 squared, square root of 6 squared plus 4 squared. And that comes out, for me, that comes out as 2, in fact, we'll just do it as 6 squared plus 4 squared. And that comes out as 52. So it's a square root of 52. This is an exact value. So your AC is equal to root 52, which is perfect. But if we square root that answer, we also get, it also comes out as, you may want to use it as this, 2 root 13. I think I would use root 52 to be honest. But if you did that, root 52, and then got it as a decimal, it would be 7.21, and that's going to be centimeters. Okay, to 2 decimal places. Now, if I need to use AC in another part of the question, we use this thing here. That's what we're going to use. If we need AC again, this is what we use. The next bit says calculate the angle BAC. Oh, very lucky that I used this triangle. So BAC. So it is actually this angle we're looking for. BAC is in here, and we've got everything we need. So for part B, I'll do my part B over here. I'm going to just draw that triangle again. There was my A, there was my B, and there was my C. That was 4, that was 6. You could use the new side that we found. I don't think we need to. We'll just use SOHCAHTOA for this. So this is my opposite side, and this is my adjacent side. And tan, remember, from SOHCAHTOA, I've got my A and I've got my O. So we're using this one, which stands for tan of my angle theta is equal to opposite over adjacent. And that means tan of theta in this case is equal to 4 over 6. And then just do tan to the minus 1. Theta is equal to tan to the minus 1 of 4 over 6. I haven't left myself enough space yet. And that means your theta works out the angle. Let's just do that. Tan to the minus 1. Tan to the minus 1 of 4 divided by 6. And that works out to be 33.69 degrees. And that's the 2 decimal places. Okay, next one. It says AG. Where on earth is AG? Let's clear this up a wee bit and let's look for AG. So AG it's what's called your long diagonal, because it's from the top back left to the front bottom right. So that's the longest diagonal. So let's create a right angle triangle. And this would be a right angle triangle. Okay, now let's just draw that out. So for part C, we've got our A down to E, and the height of AE would be 3. And then you've got a long, to E from E to G. And then you've got your long diagonal. That's what you're trying to find. I'll call that X. Okay, right. Now, if you think about it, what we've just found earlier on, we found A to C. A to C is directly above E to G. So this is the same. My E to G is the same as my A to C. And A to C we worked out as the perfect answer of root of 52. We're going to see how easy it is to work with this then. So in this one, x squared, my AG is equal to 3 squared plus root 52 squared, which means x is equal to the square root of 3 squared plus root of 52 squared. Now, if you do that, what you would get, let's just work this out. 3 squared is 9, and root of 52, if you go on your calculator, if you do root of 52 and then you square it, you get 52. So it actually leads us to an exact perfect answer for my root of x. So all of this I've done, to be honest, without my calculator. X is equal to the square root of 61. So it's going to be 7 point something. So let's just do that and see what the value is. Square root of 61. Bear with me, play with a new calculator here. So that's 7.81, and that's going to be centimetres to 2 decimal places. But again, if I need to use this, or I should have labelled that. Apologies. Call this, label this thing as it is, as I wanted it. We wanted AC, so we'll call this thing AG. So AG is equal to this, and if we need to use the value of AG later on in the question, we're going to use this one because this is the exact value, the square root of 61. The last thing I want you to find is the angle CAG, C to A to G. So let's find a right angle triangle which involves C to A to G. So there's my C to A to G. So it's down here, and my right angle would be here. So let's draw that triangle out. So A to C to G. So this is my last part, part D. A to C to G. You've just worked out that your AG was root of 61. We also know C to G is this height, and it's the same as over here, so it is 3. So that's 3, and we want the angle C to A to G, so CAG is going to be this wee angle in here. So again, we can use our SOHCAHTOA. So relative to your theta, 3 is the opposite. This is my hypotenuse, so my angle, I'm going to be using sine, because, going back to this, sine is equal to opposite over hypotenuse. So sine theta is equal to 3 over the square root of 61, which means theta is equal to sine to the minus 1 of 3 over the square root of 61. And we'll do that on our calculator. Shift and sine of 3 divided by the square root of 61. And that is my theta, my angle, works out to be 22.59 degrees, and that was the 2 decimal places. Okay, so there we have the answer to them all. And you can see the big takeaway from this, when you get a side, use the exact value. If you need to use it later on, use the exact value. And that is us.